Okay guys, if you've come back, that's a good sign. You hopefully understood what I was going on about before. This is domains and ranges for methods year 12 course. So you should have learned a fair bit of this in year 11. However, domains are the possible set of x values that you use in a function, and the range is a possible set of y values that you use. So if I sketch one of these graphs here, state the domain and range of each. So this graph here is a parabola, and it's been translated 3 units to the right. So it starts at 3. Sorry, it doesn't start at 3, it turns at 3. If you're unsure about it, remember when you've got y equals x minus a squared plus b, your turning point is at AB. In this case here, my turning point is at 3, 0. Because it's a positive x squared, it's got to be a happy face, so it's going to go up like that. Okay, it says state the domain and range. So my domain, well, x can be any value. There's no restriction, so we say x is an element of all reals. Y, well, and this is one way that I do it. I swipe the pen from left to right. So if I go from left to right, I'm always going to be touching the graph, so that x is an element of all real numbers. If I put a pen here and then I slowly move it up like this, the first time that I hit the graph is when y equals 0, and then it goes up to infinity. So my range is y is greater than or equal to 0. Or you could say y is an element of 0 inclusive, because the first time I hit it is at 0, up until infinity. Either is fine. You need to know both ways because they could ask you anyway in an exam. With this question here, we're actually given the domain already. X is greater than 0. So we know domain x is greater than 0. The main thing we want to do here is find the range. So if we look at this function, we know it's a straight line graph. Let's work out our x and y intercepts. Now we know x can't equal 0, but we'll find what x would equal if it was equal to 0, because we know that we've got to put an open circle there. So what I would do, if we let x equal 0, we're going to get that's 0, so we get 3y is equal to 12, so y is equal to 4. So let's say there's 4. And then if we let y equal 0, that's going to disappear, and we're going to get negative 4x is equal to 12. So x is equal to negative 3. So x is equal to negative 3. There's negative 3. That's when y equals 0. So our graph's going to look something like that. Although that doesn't look right, because we know that our x-intercept is negative 3, but x is greater than 0. So is that the right way? We've got our y-intercept. So we've got our y-intercept. We've got our x-intercept, but x can't equal negative 3. So we can't go that way. So we've got x is 0, y is 4. Let's choose a point to the right. So if we let x equal 1. If we let x equal 1, we get 3y minus 4 is equal to 12. We get 3y is equal to 16. So y is equal to 16 on 3, which is 5 and 1/3. So you can see from here the graph's going to go upwards. So what is the range of this graph? If x is greater than 0, so if we go across, starts at 0 and then gets bigger. Y, well, that starts at 4, but it doesn't include 4 and goes up. So we want to state our range. Y is greater than 4. You could also say x is an element of 0 to infinity. That's not x, that's y. Idiot. And we could say y is an element of 4. to infinity. So hopefully that makes sense. Just remember what I was doing with the swiping, like using a line and then moving it up and down or left and right. That allows you to see when the first time you hit the graph is until the first time you move away from the graph, so you can work out what the domain and the range is. Okay, so here I've already got a domain given to me, so we don't need to work out the domain. We do need to graph it though to work out the range. So if I put -1 into this function, y is equal to -2 times -1, which is 2, plus 2, which is 4. So I've got -1, 4, and I'll just put -1, 4 here. It's coloured in because it's equal to. If I put 2 in, I get y equals -4 plus 2, which is -2. So let's say we've got 2, -2. It's a straight line graph, so it's going to be everything in between. So we know our domain is x as an element of -1 to 2, and range is an element of, both ends are included. So if I move the graph up, the first time I hit it is at -2, and then I hit it from -2 all the way up until 4, but if I keep going up, there's no graph, so -2 to 4. Okay, not sure how many of you remember this, but this is a circle. The center is at 0, 0, and it's got a radius of 3. So if we draw this, 3, -3, 3, -3. Let's see if I can get a perfect circle. Not bad at all if I do say so myself. Okay, so what is my domain and range? Well, what x values do I use? The first time I hit it is at -3, and then I hit it from -3 all the way through to 3. So my domain is -3 to 3. My range, start from the bottom. First time I hit it is at -3. Last time I hit it is at 3. So my range is also -3 to 3. Okay, here, this is a little bit tricky. This is a function where it's just single points, like coordinates. So I've got -1, 2. It's just a dot. I've got -1, -1. Just a dot. 0, -1, 0, 2. Okay, so if I want to state my x values, well, x is an element. We don't have a range of values here or an interval, we've just got single values. So x values I use are -1 and 0. Y values that I use are -1 and 2. So that is my domain and my range. Okay, here I've got a parabola. Now this is one of the most common things that kids stuff up, because what they always think, because they're used to straight lines, they think if they sub in the endpoints, they'll be able to work out what the highest value and the lowest value for the graph is. So I'm going to show you, if we did that, if I put -1 into this graph, I would get 1, but with a round circle, but with an open circle because it's round. And I could put 2 into it, and if I put 2 into it, 2 squared is 4. So let's say that's 4. Now if you did that, you would say x is an element of -1 to 2. Y is an element of, that was 1, with a round bracket, up until 4 with a square bracket. However, we know that a quadratic goes down and then up. Oops, my scale here wasn't very good, was it? Let's change that to a 2 over there. Okay, so the reality is my range if we draw that line, when's the first time I hit the graph? I hit it at 0, and it's included all the way up until 4. So my range is not that. Y is an element of square bracket 0, because we include 0, up until square bracket 4. So that is my domain and range for that function. Okay, so that's it for domain and ranges. Soon we'll look at relations. I'll just show you on your calculators how you can sketch this and have a look for yourself. So -1 to 2 and x squared. So on the Casio, I go x squared, keyboard math 3 given, what was it? -1 to 2. -1 is less than x, which is less than or equal to 2. Sketch it, zoom, initialize. So there's our graph, and you can see our bottom value. You can use fmin if you want, so gsolve fmin. Our bottom value is 0. Analysis gsolve fmax. Our top value is 4. If we want to do it on the class pad, forgive me, I know how to use the normal calculator, but on the iPad it's pretty funky. So if I go add graph. So if we go x squared given, I have no idea where it is on this calculator. It's not that one. No. So what we've got to do is long press them. Nope. So we basically want that symbol given. I don't know what's going on there. Have I put, or maybe, okay, given. And then we say -1 is less than x, which is less than or equal to 4. Hit enter. There's our sketch. Now you can't move it around like you can with the other CAS, but we can also go analyze graph, maximum, and then move it across to here and then here. And that was stupid. Try it again. Maximum from there to there, yeah. So 416, and then if we go that minimum, and we put that one value there and one value there, it says it's 0, 0. So we worked that out, minimum and our maximum, using the CAS. Okay, I'll continue on with relations and functions soon.